to wrap this up, reproductive isolation. So the two types of isolation are either geographic or reproductive isolation. In this case, there doesn't have to be a physical barrier that separates the population. Okay. In this case, they could be something else that caused them to become isolated. So there's three different types. So we have post-mating isolation. Post means after mating. Behavioral, which is pre-mating, and temporal, which is also pre-mating, before mating. So let's take a look at each one. So post-mating isolation, there's two parts to post-mating. Either they can mate, but they can't produce any offspring. If that's the case, then they're definitely two different species. So in post-mating isolation here, they can mate together, but nothing is formed. Second possibility is they can mate and they can produce offspring, but there's a problem. The offspring cannot have babies. So classic example is the horse and the donkey. They get together, they produce a mule. The mule is infertile, it can't produce any offspring. So mules can't get with horses and have babies. Mules can't get with donkeys and have babies. Mules can't get with other mules and have babies. They're infertile. Okay. Another example is the liger. No, it's not like what Napoleon Dynamite says, that it's a mythical creature. It's a creature that actually exists. So here's the example. A female tiger gets with a male lion, and they produce the liger. Now, up until recently, it was believed that ligers were infertile. In very few cases, ligers are actually able to reproduce. So ligers can actually have babies, some of them. But for the most part, we would still consider a tiger and a lion two different species because most of their offspring are going to be infertile and not be able to reproduce. All right. The second type of reproductive isolation is behavioral isolation. And with behavioral isolation, you have a population of the same species living in the same place. While they live in that same place, some individuals start to behave differently. Now, it sounds weird to us as humans, but in the animal kingdom, behavior can make a big difference. So in the animal kingdom, if you behave differently than what the species is used to, you might not be able to mate at all. Okay? So in behavioral isolation, usually has to do with a behavior that they use to attract a mate. So if you have a group of organisms that are the same species, a population living in the same place, and some individuals start to behave differently to attract a mate, that can cause isolation right there in the same place. So even though they live in the same place and they are the same species, you've created isolation. So here in this example, this is the eastern and western meadowlark. And what happened here in this case, they were originally the same species, but some individuals started to sing a different song. And as a result of that, they branched off to form a different species. They no longer will mate with each other. Okay? Because what happens here is the female listens to the song that the male sings. And in the case of like the eastern meadowlark, let's say we started with the eastern meadowlark here, and the females listen to the song, all the males sing the same song, and the females pick the males that they feel sing it the best. Well, all of a sudden, some males started to sing a different song. Most females didn't like the way it sounded. They weren't lucky. They weren't getting lucky. They weren't mating. But on a small chance that some of them got lucky, some females actually liked the sound of that song. So let's take a look and let's listen to how these guys sound, how they are different from each other. So here's the eastern meadowlark, and here's its song to attract a mate. Okay, and here's the western meadowlark. Okay, so even though these guys live in the same area, they have become isolated based on their behaviors. Eastern meadowlarks only like the sound that the eastern males sing. Western meadowlark females only like the sound that the western meadowlarks sing. So they have become behaviorally isolated. Okay. Another example, this is a really cool one. This is the blue-footed booby. This is a bird that lives in the Galapagos Islands. And what it does, it does a certain dance. So this is a behavior that it does to attract a mate. And if the female likes the way the male does the dance, then it'll be attracted to it and want to mate with it. So let's take a look at what its mating dance looks like. Alright, so in this case, in this behavior, you can actually even see it in this video. The male that originally started the video, he was dancing, and this other male starts dancing, and the female was more attracted to the way this one was dancing. So the female went up and started dancing with him as well. So imagine if some of the blue-footed booby males started doing a different dance. And it might be that none of the females like it, and they don't reproduce at all, and that dance just dies off. However, on the off chance that some of the females actually like the dance and they're attracted to it, that can cause behavioral isolation. Although all the blue-footed boobies live in that same area, all of a sudden they become behaviorally isolated because these guys are doing this dance over here, these guys are doing this dance over here, and you've actually created two different gene pools. So these guys will only mate based on the dance over here, these guys will only mate on the dance over here. You have natural selection, genetic drift, mutations, natural selection, genetic drift, mutations happening here, and it causes changes to add up over time until you get two different species. Alright, oops, didn't want to do that. Alright, last type of isolation is temporal isolation. Okay, temporal has to do with time. In this case, it has to do with what time of year the species mates. Now again, as human beings, it doesn't seem like that big a deal. As human beings, we're kind of one of the rare species where we can mate 24 hours a day, 7 days a week, 365 days a year. But out there for other plants and animals, they mate only during a specific time of the year. And they usually will not mate any other time of the year. So that is their window of opportunity. If you don't mate during that window, you don't reproduce, you don't have offspring. Okay, so here we have a picture of orchids, so using plants as an examples. These are all different species of orchids. So if we look at those species, maybe these guys only reproduce during March and the beginning part of April, while this species only reproduces towards the end of April, beginning of May, and this species only reproduces during June. If that's the case, if that's the only time of the year that they mate with each other, they reproduce, then they are not going to reproduce with each other. So again, if we started with one species of orchids living in an area, some started reproducing at a different time of the year, that would cause temporal isolation. So even though they live in the same area, they're reproducing at different times of the year, they're not going to reproduce with each other. Same thing can happen with organisms, with animals as well. So let's say there's some animals that reproduce during the month of September. Okay, and so it's a same species, a population, they all reproduce during September. But for some reason, some individuals in the species start to reproduce only during November. Okay, so you had one species, one population, and now they become isolated. Not by a barrier, but they're still living in the same place. But these guys reproduce during September. These guys reproduce during November. They've become isolated. They're no longer going to mate with each other. So you've created two different gene pools here. And in this gene pool, for this part of the species, natural selection, mutation, genetic drift, natural selection, mutation, genetic drift, changes add up over time, and now you create two different species over time. Oops. All right, so the big ideas with speciation here. Isolation and the big three. That's what causes species to form. So if you have a population, a species, that becomes isolated somehow, either physically, behaviorally, temporally, once they become isolated, changes add up over time. Natural selection, genetic drift, mutation happens here. Natural selection, genetic drift, mutation happens over here. They change to become so different over time that even though once they were the same species, they have changed so much that they are no longer the same species. If they did get back together, they either wouldn't or could not mate with each other.